questions.
Okay.
Okay, so I just started recording, and basically you're asking about the first problem so far, and you told me that it was kinetics. So we got two different bodies there. So in general, I'm going to actually draw two different free body diagrams and two different kinetic diagrams. That make okay sense?
Yeah.
Okay, so for the first body, I think I told you guys a little bit about this. What I tend to do is I just draw, I'm defining my system, right? So there's kind of body A, and what forces are acting on that?
So it's the weight of the mass down, so the 200 pounds down, and then the tension up.
Perfect. Okay, so we got this, and then up we got tension. Okay, and then what would be going on, do you think, with the kinetic diagram?
Would it just be the mass times the acceleration in the y direction?
Yeah, and so you have to be careful about how you decide you're going to set it all up when you do it. Does it make sense that that would probably be going down?
Yeah.
Okay. So then we have another system too, right? So we got this 100-pound one. Okay, so then if I'm going to draw that down here, so what do I have acting on there in terms of the weights and the forces and stuff?
So it's the weight down, the 100 pounds down, and then tension up.
Okay, so we got the tension there, right? And then I could do my M, and maybe I call this B times the acceleration of B. Okay, so where that would be, maybe I should have done that a little bit better. Right? That's M of A, and the acceleration of A and the Y.
Mm-hmm.
Is that okay?
Yeah.
All right, so do I know anything about the two T's there?
So the T is equal, but they have different values, so I was really confused.
So what do you mean they're equal but have different values?
Because it's the same cable, so tension... Oh, I guess the tension B would be less than the tension in A. I'm not really sure.
That's right. Think through it. So I like listening to what you're saying, Sydney, and it's fine if you're not quite right or whatever. It's just as you talk through it, I can then point out things like, oh, this is what you're thinking where it's maybe a little bit off. So keep thinking, keep telling me through. So you were talking about the tensions, right? And first you said they're equal, and then you said they're not, and the numbers are different or the numbers are the same?
So the numbers are different. For mass A, the tension would be 200 pounds, but in mass B, it would be 100.
Okay, so that's true if it was static. Do you know what I mean? Like,
yeah.
Okay, but it's the same rope, isn't it?
Mm-hmm.
So, and if I don't have friction along through here, you know what I mean? Because friction through there would affect how it would go. But if it's the same rope, it's actually the same tension.
So would it be the 200 pounds?
No, it's actually, you don't know what it is.
Oh, great. Okay.
Okay, so, and I agree, that's a little confusing, right? Because if you just looked, if I just looked at this and I was only thinking about statics, right, then,
mm-hmm.
Yeah, sum of forces is equal to 0, but it's not. What is it equal to?
The mass times the acceleration.
Yeah. Okay. So now for this one, I would say, if I set that going down, maybe that's my plus for this one. So then I would have minus T and then plus 200. And remember, the one thing you guys sometimes get frustrated about is there's multiple ways to solve these problems, right? There's no exact right way typically. So does this make okay sense? So this is that, I might have done that wrong. Let's see. Did I do that okay with the pluses and minuses?
Yeah.
Okay, so now tell me, what would I do right for this system here?
So it would be negative T plus 100 equals MBA BY.
Okay, so if I do that, right, so, I'm sorry, that you told me that was equal, right?
Yeah.
So if I do this, right, if I look at my picture, which direction is my T going in?
Oh, wait, it's going up.
Okay,
so it would be a positive T and a negative 100.
Yeah, so it just depends on how you set it, right? So the big take home here is that the T and how I drew my diagram is those two have to be the same sign. Do you understand what I mean there?
Yeah.
Okay, so I could write this, like I said, there's a couple different, shoot, let me see. Hold on for a second. Let me see if I can erase now and then. This doesn't work as quite as nice as I'd like. There we go. Okay, so basically then I would have the plus, hold on, sorry. Wow. All right, hold on. I don't know what I hit there. Something went funky. Hopefully that's... shoot, okay, wait. I think I can figure that back out again. Give me 1 second. So I want to share the screen. Give me 1 second. All right, so I need to share. All right, hold on. Something's gone weird with my... Okay, let's see here. So what are you looking at right now on the screen?
Meeting topic, Brian Sells personal meeting room host.
All right, let me see. What do I want it to do now? So I'm trying to share a screen, but it's not giving me... All right, now what do you see?
Oh, hey, now it's the Polyland screen.
Gosh. All right, give me a second. I want to do a new... let me try again. Share screen. Okay, I see it now. It just wasn't up there the first time. All right, so can now do you see it?
Oh, there you go. All
right. Sorry. All right, so now we're at this screen here, right?
Yes.
So basically, I look here, and I look here, right? And do I know anything about AB and AA?
The same but opposite?
Well, it depends on how I drew it, right? So I agree with you that they're the same, right? If that's going up at 2 meters per second, that's going down at 2 meters per second.
Oh, but they're drawn differently, so they're both the same.
Exactly. Okay. All right, so let's talk about this again. Let's look and see there. Since I don't have any friction or mass in that pulley, then that means the tension in the ropes there is the same. Same thing for like that weightlifting problem we did. Remember just last time where I'm pulling on the rope and I ended up with 4 times the tension? Did you look at that?
Yeah.
That full solution. So the tension of that rope's the same. Okay. And then you just told me that the accelerations were the same because of how we drew it. Now, if I had drawn that differently, I might have had I could end up having something like A of A equals minus A of B, depending, like if I had drawn this one over here going down, like maybe I decided I was going to draw that, and that's fine, but then I would have had this. Do you understand that or not really?
Yes.
So if I drew this going down, I just assumed, right? Because I don't always do things the same on all these, right? Or you might not have thought about it the same way that I just showed you, and that's fine. But it's really tough sometimes to keep track of all your signs. You have to be really careful about that.
Yeah.
Okay? So I'm going to kind of scribble this out because we're working with the other way now, right? Okay, so this is equation 1. Right? And that's equation 2. And you just really told me that acceleration of A is equal to acceleration of B.
Yeah.
Okay? So that's equation 3. And what are my different expressions that are kind of unknowns here?
So the unknown would be T. And then the acceleration.
Yeah, so I don't know T. I don't know acceleration of A. I don't know acceleration of B. Right? What just happened now? Oh, this drives me crazy sometimes. Sorry. How do I... okay, resume the share. Okay, so... I'm actually okay technology-wise, but this one, like, this is a newer app that I just started using this time because they sold out on our old one. And I'm not as good at it as I was at Illuminate. But anyway,
No worries.
so how many equations do I have?
3.
How many
and
unknowns?
3 unknowns.
Yeah, so really all you have to do is plug like A into here, right? And then you have a T here, and you got a T there. So you can solve it in whatever way you want, right?
Okay.
2 equations, 2 unknowns. That makes okay sense to you?
Yes.
You sure?
Hold on. So I can substitute in like A or acceleration of A and for the A of B in the second equation.
Uh-huh.
And then can I do like a systems of equations thing where it's like you can cancel out the T's?
Yep, exactly. So you could do like this, right? So if you wanted to do, so what you're saying is this would be now another equation, right? So that would be like equation 4, right? And then you could do up here, hopefully I won't make it do something funky. So now you'd have, this equals MA, AA, right? And then what you just told me you want to do is like minus 100 equals MB, but you just told me that those are the same, so I could do this. So now if I wanted, I could add these two together, right? And then you get a 0, right? And then you could do the rest there, and you could then solve for acceleration of A.
Okay.
Is that all right?
Cool. Yeah, I think I got it.
So you get acceleration A, and then automatically, acceleration of B. Then you can plug that into equation 4 or to equation 2, either one, right? However you go, and then you can solve for T. And then you can check it all, right? So make sure that this T equals what you would get for subbing in this T.
Okay. I think I got it. And then for like part B where I asked for the velocity, is that just the ADS equals VDD?
Yeah, because acceleration is a constant, right? So you can use ADS equals VDV since you have velocity and now it's asking you about distance, right? And in fact, since that, the forces are constant, so that means your accelerations will be constant. So you can either use ADS equals VDV, or you can even go back to your regular physics equations like, V squared equals D naught squared plus 2AD.
Okay.
Does that make sense?
Yeah.
But I always like you to go to the ADS equals VDV, because it just gets you practicing doing those things.
Yeah.
Rachel, can you hear us? So it looks like you're talking, Rachel, or something's going on. Here. Okay, looks like Andy signed on too, so I can hear Sydney, but I can't hear anybody else yet. But you guys can chat in if you want to. Let me open up my chat box to make sure I can see if you're doing it. So, go ahead, Rachel.
Can you hear me now?
Just barely. Did you go through the audio wizard?
I don't think so.
Okay, I can just barely hear you. Sydney, can you hear?
A little bit.
Okay.
Oh, that's better.
Okay, I'll just talk loud.
Okay. So let me double check. So Sydney and I just went over the first problem.
Okay. My only question for the first problem is you're still using like the sum of the forces equals MA, right?
Yeah, and give me one sec. Hey, Sydney, can you mute yours? You've got a bit of background noise coming in. Okay, go ahead, Rachel.
So then when you're using the sum of the forces, why do you use the net instead of adding them?
Okay, so you've got two different ways you can do here, right? So one is sort of the net, like what we talked about. But what I would do here for these ones when you're trying to solve it mathematically is, since you have two different bodies, let's just draw two different free body diagrams. Okay, so this, and that's what we did, two different FBDs and two different KDs. So, and I'll make this recording available to everybody too, but this would be my first FBD and my KD for A.
Okay.
Does that make okay sense to you?
Yes, I believe so. And then would you set the accelerations equal?
Yeah, and if you look, because here, remember, if you look at, here's the second one down here. So this is what I did for B, right? So if I call this one B, right, then there's another free body diagram and kinetic diagram. Okay, so if you know what we decided to do, what Sydney and I worked through is we said, well, we're going to have this one go up, right? So if that one's going up, then numerically that one's going up and this one's going down. Does that make sense to you?
Yeah.
Okay, so if that's the case, then those are equal algebraically. If, however, I had decided to draw this MBAB going down, then numerically I would have that, and that's what I did over here, where I said acceleration of A equals minus acceleration of B. So a lot of it depends on how you end up drawing out these diagrams and just trying to make sure you're consistent with your signs.
And then for the middle one where there's not
Like, I lost you. Can you talk a little louder?
Hello?
Yeah, I can just barely hear you.
Okay. For the second one where there's no weight on the end,
Uh-huh.
what do you do with that? Is it just like a massless force, or like would you represent that as an upward force on the other weight?
That's just a tension is all that is.
Okay. So you only have to do one free body diagram for that one.
Yes.
Okay.
All right, so
Okay.
give me a second. I'm going to turn my screen up because every now, I don't know if it sometimes hits my touchpad or what. Give me 1 second. So, because I don't know if this just stopped sharing again or not. All right, so can you guys still see the same screen?
Yeah.
Yeah.
Okay. So, and let me see, because maybe so my audio's turned up all the way. Wait, give me 1 second. I wonder if I've got my... that's what it was. Sorry, I've actually even got like a little. I'm so fancy. I got this. My headset has a little volume adjust thing too, and it was turned low. So
Okay.
now I can hear you. Sorry.
It's okay.
I've really done this before. I promise. Okay.
I
So
have a question.
go ahead.
Oh, okay. Wasn't quite sure if you could hear me or not. So in your representation in class that really made sense for me was when you laid it out flat. How would you find the net force from that? Because here in the free body diagram, you have like tension and all sorts of things. Like, how would you represent that?
Yeah, so I'm gonna page down for a second. So, the problem with the flat one is it makes it harder to kind of figure out what the tension is in between. So, but you could try to go through there, and basically how we would draw this out is that's my 200, right, and it's connected to the 100, and then this would be like a 100, and this would be like a 200. Okay, so that would be pounds. This would be pounds. Then you have to remember the mass there is going to be 32.2. And the mass there is going to be, 100 over 32.2 because that's what you do, right? For mass is equal to the weight over G. Okay? So if we looked at this, that should be fairly straightforward to go through and figure out, what your sum of forces is like in the X, right? And then your mass would be your mass A plus mass B, right, times your acceleration, because the two accelerations are going to be the same. Okay, so the issue there, though, it gets a little bit harder to just solve for the T. So like I was telling Sydney before, these things end up where it gets hard because, there's multiple ways to solve these problems. So what we did on the first page is we said, I've got two free body diagrams, so I've got two different bodies, so I'm going to draw two free body diagrams. right? And then within there, so this is going to be a little cleaner now that you guys can see. So I'd have this 200 and that T, and then my kinetic diagram, because I looked at it and I figured, hey, this MAAA is going to go down, right? And then for the second one, I would have, I'm going to draw it way over here. Basically, I would have a 100 going down, the T going up, right? And then for this, it would be, we decided that one would go up. So this is the MBAB. So you could really work it both ways and then try to figure, see if you got the same accelerations.
When you divided that the weight by 32.2, is that giving you your answer in kilograms, or what?
No, that's what we call a slug, and I
Oh.
just barely mentioned it in class towards the end, right? Because when I said, we rarely talk about the mass
Mhm.
in when we talk about English units, so nobody really ever says, I weigh 5 slugs, right?
Right.
Or you rarely talk about kind of the mass that way, like we do with 100 kilograms. Guys, but it's the other way to do that is you would say, like normally it's 4.45 newtons equals like 1 pound.
Okay.
So let's just say, that would be about 800 newtons.
Mhm.
Right? So let's say I weigh 800 newtons. Right. In general, what you would really end up saying is how people, and this is just vernacular, how you'll talk is you would give that in terms of kilograms. Okay. So instead of that, I would probably end up saying, that I'm about 90 kilograms or I guess really more 80 something kilograms. Okay. And that would
Okay.
be my mass. Right.
Yeah.
Where 800 is really a force.
Okay. So when you get it in slugs, is that what you're using as your mass?
Exactly.
Okay.
Is anybody in? Nobody's in thermo yet, all right? Maybe the arrows have had some. So there's
No,
this.
we don't take thermo until third year.
Okay, so have you talked about pounds mass or pounds force yet?
We did in our intro class, but just briefly.
Yeah, so we only talk about pounds force in mechanics stuff. So the thermofluid side has kind of this pounds mass thing they talk about that's not used anywhere except for there. So pounds mass and slugs are not the same thing. So that's that's why the entire scientific community uses the metric system. It's just so much more logical.
Yeah.
But you may want to have yourself a little bookmark, or really the best thing to remember is later on if you're out working that you just have to remember that you better look it up to make sure you know which one you're talking about.
Okay.
Okay. But for this class, we always just use pounds force.
Okay. And then if you use the slugs as your mass, would your acceleration still be in meters per second squared?
No, what's it going to be in?
I don't know.
We're in the English system. So if it's English system, it's not meters per second squared, right?
No. Would it be feet or inches?
What do you think?
Probably feet.
Yeah, because remember 32.2 is feet per second squared.
Right. Oh, okay.
Okay. Yeah, so I always recommend if you're dealing with English stuff, just change everything to slugs and everything to pounds, and then slugs, and then everything to feet right away. Yeah, just because it just gets too confusing if you're doing kinetics problems.
Yeah. So I tried converting it all into kilograms and stuff, and I think I might have gotten it right, but I don't really know. So I'll redo it.
Yeah, you may be able to still get it. That's definitely one way to go through and do it, right? And then you convert it back at the end.
I have a quick question.
Mhm.
So for the experiment that we did in class, you set your net force equal to MA. That mass, is that the total combined mass of the system?
Yes.
Okay. And that's why the acceleration for the one where it was just a force was different?
Yeah, so it's not right, which is basically case 5 that we talked about is really comparing these two, isn't it?
Yeah.
Yeah. So in this case, if I did the horizontal way like you asked me, then what would my block be? What's my mass?
What? I didn't hear that question. I'm sorry.
If I did it like what you had me do here for this part, right? If I do it horizontal, then what's my mass if I'm looking at case 2?
Yeah, the mass of the block would just be 200 pounds divided by 32.2.
And then what force is going to the right?
100 pounds.
And then what force is going to the left?
200 pounds.
Yeah, because that's the weight, right, of the 200 one, right? So then I would look at this one, and that net force is 100 pounds going to the left. And if I look at this one, which is kind of case 1, then what's that net force?
100 pounds.
Acting to the left. And so how much total mass is in case 1 in this one here?
I don't have a calculator on me right now, but it would be more than the second case.
Exactly. And, you guys can start doing some estimates, right? So 300 over 32.2 is, right, about 10-ish, right? Slugs. I mean, a little, you can kind of get those estimates there between 9 and 10. And then 200 divided by 32.2, right? You can say between 6 and 7, right? Did I do that okay?
I think so.
Yeah, so you can start doing some estimates there, at least to get orders of magnitude type of thing. So that's why I sometimes ask you on the online quizzes to do these estimate type of things, because a lot of times if you guys are in the field, depending on what your job's like, that's the type of thing you're going to have to think about doing when you're making decisions.
Speaking of quiz, do we have one tomorrow before class?
No, I didn't get one of those made. Like, if I don't have it made by like 9 o'clock this morning, then it's not fair for me to spring it on you later. So I didn't get it done in time.
Okay.
Abdullah, do you have any questions? You haven't been able to ask anything yet. You can chat in if you don't have a mic that's working. Let me check the chat box. Hold on. Where did that go? Okay, and if it doesn't, like I say, you can sort of chat in if you want to. All right, while he's working on that, does anybody have other questions?
Not about this problem.
Oh, go ahead, Abdullah. I think I hear you.
Okay. And this might be a kind of simple question, but something that's always really confused me. So, when drawing the free body diagram for like mass A, the tension is like relative to that mass. But then if we say look at the tension take the free body of like the 100-pound mass, that like if we were to do that first, that tension would be like respective to that 100-pound mass. So how does that work? How is it? Do you see what I'm asking?
Well, so I think so. Basically, if I have a pulley type of system, then kind of like what we talked about, and this is a little bit of a mess, but like I said, I'll also make this recording visible. Can the other guys online right now just mute your microphones, because I get a lot of background noise? So if you can mute for now, and then once you're ready to talk, you can unmute. So if we look here, then what you got is that the, if I don't have any friction along the pulley, then what ends up happening is this tension, which you see right here, right? And then the tension that's acting on B, which I drew down here, right? So I have two different bodies. So I've drawn two different free body diagrams and two different kinetic diagrams. So there's a tension T going up here, and there's a tension T that's acting up in the A, right? Because that's what all rope does is pull. So you should actually, I should have asked on this question, I guess I didn't, but you should solve for that tension and just see what you end up getting. Right? Is it 200? Is it 100? Or is it somewhere in between? Right? So basically, how Sydney and I talked about it is, this is the basic F equals ma equation for right here, right? So I got a t up, and in this case we set our positive going down. So t is in the negative, and then 200 is in the positive, and this may was in the positive. And then when I looked over at this one, I decided to set my positive going up, and I said t was up, and that's down, right? So now I have these different equations, and if I don't have any friction in the pulley, okay, and I don't have any of this axial friction, and the masses are small, and that's what it's saying here, neglecting the axial friction and the masses of those pulleys, then basically that's telling us the tension is the same in both of these ropes, right? So in this side of the rope and that side of the rope, the tension is the same. Does that answer your question, Abdullah, or not really?
Yeah, I mean, I guess I'll go and do the calculations for that to convince myself.
Okay, yeah, and that's what this whole thing's about, right? So first we do the in-class thing to get the concepts down, and then we do the calculations to help reinforce, hopefully, to reinforce it.
Yeah. And I guess second question is, so when we're like writing out, when we're trying to solve this, we can't just do like the 200 pounds, like the force of the 200 pounds minus the force of like the 100-pound mass?
Yeah, so as we had talked about a little before, where there's multiple ways to solve these problems, right? So one of the ways is, since there's two bodies, you end up with one equation up here, right, which is my equation number one, and one equation down here, which is number two. And then I also noticed in how I drew it that acceleration going up, right, because that's going to go up and this one's going to go down, if those two are the same, then basically I end up with two equations and two unknowns. And then up here, Sydney was talking about how she wanted to solve it with this system, right, where you just add the two together. You could also solve this one for t and throw that down here. So you could just solve this one for t and then throw that up there. So there's there's a bunch of different ways to solve it. If we did it like the system that we talked about down here, right, which is, maybe a little bit easier mathematically, but if you guys have time, I just recommend you try to solve these a bunch of different ways, and then you check it, right? So that's what I do when I'm trying to come up with new problems, is I work it multiple ways, make sure I get the same answer. A lot of times I don't. I got to go back and figure out, all right, where did I make my algebraic error? What was my sine or cosine? Or if I'm doing a computer program, what was my syntax that was wrong? So it's always good if you got a little time to work it both ways. But if you look at it here, and this is what I think you're asking about, Abdul, is this, this is that same one there, then you got a 200 going to the left and a 100 going to the right. And then this tension between the two, right, is an internal force now. So you actually don't end up finding that one in this system, where if you do the two different ones, right, then you solve for that t.
Yeah. I think this second method was kind of what I was talking about, because then it'd just be like the 200 times mg, times g minus 100 times g, and then that equals the combined mass times a.
Well, it's not times g, because the 200, right, this is just a force, so it's just 200 minus 100 equals the total mass times the acceleration of the thing, where the total mass would be 300 divided by 32.2.
Yeah, I was just kind of like oversimplifying. But yeah, for sure.
Okay.
Thank you.
Sure. All right, other questions?
This is also kind of a simple question, but if you're setting up the free body diagram for the same pulley, so you have the free body diagram with A and B, does your coordinate system have to be the same for both of them?
It actually does not. Okay, it's not a bad idea to keep it the same, but and maybe that would have been less confusing. So I could have set both of, in here on this side, remember I actually put that one going up and that one going down, just so that it would match up to my accelerations. But as you could have switched it the other way. The most important thing here is to make sure that like this guy, since that's pointing down and this one's pointing down, that they're the same direction in that equation. If you had decided to do both of them going up, right? So if instead, let me change a color here. I know this thing's getting getting a little bit messy. Hold on a second. Let's see. If instead I decided to make my positive going positive up like that, then what I would have ended up having for my equation would have been then a minus t. The plus, that would have been plus t, then a minus 200, and then that would equal the minus m a of a. If I'd set my positive going up, does that make sense to you?
Yeah. I was just earlier. I was trying to do it, and I just ended up having to take a square root of a negative, and I know I just messed up my direction.
Yeah, and that's exactly what happened. Is somewhere in there, either, so right here I drew it so that my accelerations, that one and this one, would be equal numbers, right? But if I had drawn both of my accelerations going up, right? If I had drawn my MA, if instead I'd drawn MA, AA going up, right? Then I would have ended up having to use this right here.
Okay.
So yeah, you got to be really careful on how you're keeping all your signs consistent.
Okay. Thank you.
Sure. All right, more questions.
I have a quick question. So for part B of this question, it says to find the velocity after it's moved through 10 feet. So how do so from part A, we can find the acceleration.
Yeah.
And then do we just take do we just differentiate it, or I'm a little confused.
Yeah, Sydney, are you still there?
I'm so
So do you remember what you told me to do for B? Can you explain that to everybody?
So it's the ADS equals VDV equation because they give you the 10 feet. So if you find A, you can integrate it according to length with the 10 feet and then find velocity.
Okay, so that makes sense. So you've got a constant acceleration, right? You know what acceleration is. Like Sydney was saying, you've got the 10 feet, which is a distance, and you're trying to find velocity. So you can use the ADS equals VDV, where A is whatever acceleration that you found from up at the top, right? So you find that acceleration, and then you know that the feet is right there. So ADS equals VDV, and on the right-hand side of that, when you integrate, it's just V squared over 2, and you solve for the V, just like what Sydney was saying.
Okay.
Couldn't you just use kinematics at that point?
Well, it's all kinematics, really, Abdullah. So I think what you're asking is, can you use the constant acceleration physics kinematics equation, like V squared equals V naught squared plus 2AX?
Yeah.
Yeah.
Yeah, I mean, I guess that's what you get by doing that integration, right?
Exactly. So the short answer to your question is yes, right? But I always want you to be careful with that, right? So you really have to make sure that it's constant acceleration. So since it's constant force, it means it's constant acceleration for the system, right? So, but one of the things that I'll basically hammer you on a test or something is if you apply the constant acceleration equations when the acceleration is not constant. So that's why you'll see me, usually I'll work through the full integration just to get you in that habit.
Okay, for sure.
Okay. All right, more questions. And it can really be about anything now too, right? We don't have to talk about these homeworks. You can ask about polar or whatever. We're going to go over the quiz a little bit in class tomorrow too.
I
Okay.
I have a question about number 2.
Uh-huh.
Okay, so in theory, I was thinking that there should be in path coordinates, but it asks you to determine stuff in terms of tangential acceleration, and the radius is. But then they give you that equation in terms of theta, and then that kind of threw me off.
Yeah, and it's meant to a little bit. If you remember, we just barely started covering in class one of the days where this thing is what type of motion is this going in? What do you think the path of it is?
A circle.
Yeah, so it's an exact circle. So if you remember, we went through a little bit where we said, hey, that means that if I do polar stuff, then if I just look at the velocity, in that case, it's VER plus R theta dot E theta, right? But what is R dot for this system?
Is that the changing theta? No. No,
That's-
it's constant. It's 0.
Yeah, so that's going to be 0 because R is not changing, right?
Right.
But if I do, so this is for polar, right? But if I ask you that for path, right, then path is just equal to VT in the E sub t direction, right?
Mm-hmm.
Okay, so what this ends up meaning is it really depends on what I'm kind of given and asked for. If I have just a circle, right, then it ends up that, well, VT is equal to R theta dot. Does that make all right sense?
Yeah.
So basically it means that's the velocity going that way. And if I'm given it that it's 10 feet per second, that's great. But if I'm given that it's, theta dot times 30, I can figure that out too.
So is it just the same thing?
Yeah.
Oh, okay.
Right here. So it's just how I choose to express it. What is it? So the big deal you can think about is what is it that I'm able to measure with my, with whatever my measurement system is. Am I getting speeds in VT because I know what, my speedometer, my computer reads, or do I have some sort of an angular sensor down here that tells me what my theta is, right? Which is what you have with a lot of motor type of systems. Okay, so then I can expand that to acceleration. So if I do accelerations in polar, that's R theta double dot minus R theta dot squared, right? And that's in the E sub R. And then I have a plus R theta double dot plus 2 R dot theta dot, right? And that's in the E sub theta. Okay, so what goes to 0 in this equation?
The R dot.
Yeah, so that's
and the R
0.
double dot.
Yeah, that one's 0. Okay, and then theta, right, is given by this. Can I integrate that with respect to time?
Yep.
Can I integrate it a second time with respect to time?
Yes. No.
Yes.
Yeah, so I can get a theta dot, right, by just taking the time derivative of that, and then whatever I get for theta dot, I'm sorry, I think I said integrate, I meant differentiate, right? So I differentiate this once, I get this. I differentiate it twice, I get theta double dot.
Okay. So I guess what I was confused about is I know what that theta is changing at that rate, but I don't know what that means in terms of the problem as a whole.
The column is, what did you just say? Column as a whole?
The problem.
The problem as a whole. Okay. So, so let's say I just decided it was going to be, right, the total acceleration, right? If I've got, so does it make sense to you then that this is what my basic expression, I can figure that out, right?
Yes.
Okay, so when I say the total acceleration, right, what are the two types of acceleration I have?
Normal and tangential.
Yeah, so I have something like this, right, going that way, and then I have something like this going that way. Is that okay?
Yeah.
So which direction does my total acceleration go?
Somewhere in between.
Somewhere in between. Perfect, right? So this is my total acceleration, right? And that changes as time goes on, right? Because the theta dot and theta double dot are changing.
Okay.
How do I figure out what that total acceleration is?
Isn't it given?
Well, that's what my total limit is, but how do I tell my total acceleration at any given time?
You square both and then...
Yep, root sum squared. Okay. Is that all right so far?
Wait, can you say that again? I'm sorry. I didn't hear.
Yeah. So how do I figure out what the total acceleration is, right? What is the magnitude of my acceleration?
Mm-hmm.
Right. So because the person in there doesn't care what you've just defined as E sub theta and E sub r, right?
Yeah.
They just care how much is that? How much is that vector right there?
Oh, okay.
Right. So how do I figure out the amount of that vector?
It's just the square root of x squared and y squared.
Okay. So, or in this case, it's like r theta dot squared, right? Squared plus what?
Is it the r double dot?
R theta double dot, right?
Yeah,
Because you
yeah,
told me
yeah.
that-
That's what I meant.
That's all right. Yeah, so then that's got to equal, so whenever that's equal to 10g, I pass out.
Got it. So you have to derive the original theta.
Yeah.
You're not integrating it
You're taking the derivatives, yeah,
okay.
with respect to time.
Got it. Thanks.
Okay? Yeah, these are, so I've tried to make these challenging problems to kind of get you ready for the final exam that we end up getting, and that actually sounds like I might need to do a little pep talk in class next time, just because I think people are like, man, this is just too hard, but it'll come around for you. In general, that's what I've found is it's a little shocking at first because it's you're kind of used to statics in the other ones, and then it's like, oh man, this is not statics.
Yeah, definitely not.
Yeah, but you guys will get it. I mean, you guys are all bright. It just takes a little while to get that thinking around. This stuff is hard. It's not intuitive. Statics is reasonably straightforward, and this stuff is like, gosh, there's multiple approaches you can do. There's not a good menu for this. You just have to kind of work a bunch of problems and start seeing, making the connections between them.
Okay. And then at the end of this problem, it says to verify that the tangential acceleration is negligible.
Mm-hmm.
And the equation you wrote at the bottom, that would be to find the time.
Yeah, because you're going to have, right, each of these is going to have some sort of time word in there, right?
Right.
So what do you think this vector up here would look like if the t thing is pretty negligible?
Would it be like almost in the direction of the tangential, or would it be
opposite?
Oh.
Right. It would be almost, because the tangential I'm saying is negligible.
Oh! I was thinking the other way around.
Yeah. No, that's fine. Yeah. So you're thinking like one of them's going to be negligible, right? So it's, in this case, it's going to look kind of like that.
Okay, so tangential is almost in the direction of the normal, more or less.
Yeah, the tangential is almost zero, right? It means that the total is almost all in the normal.
Okay.
Is that what you were saying?
Yeah.
Kinda? Okay,
Yeah.
got it.
I have my own terms.
That's all right. Okay, so this stuff really lends itself well, and I probably should have even thought, eventually I need to start giving you a few Excel type of problems, right? So you could plot this out, and it might be easiest in the end, really, to just plot it out. Like you could have a column for t, a column for theta, a column for theta dot, and a column for theta double dot, right? And you could just figure everything out in terms of time. And then you could have another column for r theta dot squared, another column for r theta double dot squared, and a final column for this square root thing. Do you follow what I'm saying? I mean, that's what you're really going to do more as engineers is model stuff, and you're going to use MATLAB and Excel and Python and all that stuff to really look at things and parameterize them.
I'm still a little confused on the last question where it said verify that the tangential acceleration is negligible. The normal acceleration approaches 10g. Is that something we're supposed to verify through explanation and answer, or is that through equations, or can we just draw a picture like similar to what you did?
Yeah, the picture would be fine, or what do you think? What would the numbers end up looking like?
I mean, VT would equal, I mean, if it's negligible, then 0. And then would you have to do a sum of the forces, or?
Well, so I mean, if you just look at this expression right here, right, then this is going to be pretty close to equaling 100 G's, right? Because then you're taking the square root, and that's going to be really small. So basically, this is going to dominate, and that's going to be really pretty small.
And is that only because you're saying the scope of this problem to do that, or I'm confused on, like, I guess, so is that what the problem itself is showing?
Well, for how it goes. So first, first off, in general, the normal accelerations are larger than tangential accelerations for most cases, except for when you just start something out, right? Because when if you have, anytime you have like an angular acceleration, and let's just say that let's just play with the numbers, right? Let's say angular acceleration was 1 radians per second squared.
Mm-hmm.
Okay. Then after one, if I start from rest, after 1 second, right, then my angular velocity is going to be 1 radian per second.
Yeah.
Is that okay? Then after 2 seconds, it's going to be 2. Okay. But then I square it, right? So then I have r times 2 squared. So that's 4. Is that okay? Do you follow me or not really?
Yeah.
Okay. So in almost all cases, right? So basically, what I'm saying then is let's just assume that this is equal to 1 radian per second squared, right? So then at 1 second, then I've got theta. Theta dot, theta double dot, and let's just do r theta dot squared and r theta double dot, right? So if I do one column here, then that's going to be 1 now, and this is still 1. So this is going to be 1 times 1 squared, and this is 1 times 1. So then they're equal, right? After 2 seconds, right, then this is now going to be up to 2. This is still 1, right? Because if I'm just doing a constant thing there, right, now this is going to be 1 times 2 squared, and this is going to be still 1 times 1. So that's not changing. Let's look at 3 seconds.
Yeah.
That's going to be 3. That's 1. So now I have 1 times 3 squared. So that's up to 9 already, right? Where that guy's still just at 1.
Okay, that makes more sense.
Okay, so basically you're going to go through, and that's just if it's constant, right? So you never totally know, but at the very beginning of something, that's when you have to really worry about. That's like when you start your engine up or when you're first starting something, then your tangential accelerations can get kind of high. Okay, but in most engineering cases, this term is going to end up being much, much bigger than a tangential acceleration. Okay, more questions.
Because you're not given a radius, are you just finding it in terms of r?
Look at the picture. Didn't I give it? Did I draw over the picture? Oh no, I did draw over the picture. Right, I think in their radius, like right here, like 30 or something.
Oh yeah, it is.
Okay.
Found it. Never mind then.
Yeah, so that's your radius
It is given?
in the picture.
Oh, okay.
Okay. Any other questions?
I sent you a question over chat because it has to do with just the honor section, just to let you know.
Yep. So you're just going to the lab thing and then doing one of those things on Thursday.
Okay, but there's no extra homework involved?
Correct. And Rachel, I asked my contact about something extra and she hasn't gotten back to me. So let me see if I can find something for you. Right? That was you who was asking?
Yeah. Do you want me? I thought I could just find a couple of like TED Talks or something along the same lines and then do something with that. How do you
Yeah,
think?
so if you can, try to make it that you're watching like an hour's worth of TED Talk. So
Yeah, that was my plan.
yeah, that's fine. That works for me. And maybe and then supply me those too, because I may want to use them for other things.
Okay, and then do you want me to write some sort of report about it or just?
No, we're gonna just talk. So for the honors part, I just want to expand it beyond what we do in class and make you think about things other than just A equals R double dot minus R theta dot squared.
Okay.
Yeah.
So no, I'm trusting you guys to do it. And I can probably tell in the discussions because I'll ask you a couple of questions. That I'm trusting you guys, right? You're responsible students here. So
All right, sounds good.
cool.
Thank you. That
All
was
right.
all my questions.
Cool.
So, see you in class tomorrow.
All right, sounds good, Rachel.
Thank you. Bye-bye.
Thank you very much.
All right.
Bye-bye.
Thank you.
Okay. Have a good night, everybody.
Good night. Thank you.
All right. Take care.